Hey guys, hope you're enjoying your weekend so far. Today we're going to pick up where we left off with quadratic equations and actually talk about how we can ramp up our skills not just for quadratics, but for what we call polynomial equations. What we're going to see today is equations where we're not just going to have a standard quadratic or that x squared equation. We're going to see equations that actually have cubes, or even in some instances, as you see circled there, a fourth power. So we're going to basically take our skills and our solving methods from quadratics and now ramp them up and apply them to these more involved, more complex type of polynomial equations. And again, the main difference, a polynomial equation is one in which we have powers bigger than that x squared. That quadratic, that x squared, that's that quadratic. But now we're looking at powers bigger than that. So we're going to have to change our approach in a little bit. But overall, we're going to basically see our factor and solving skills that we saw early on in our quadratics unit. So here's how our approach is going to work. Now that we've talked about different ways of factoring between our standard GCF, difference of two squares, trinomial, we've also added to the mix our factoring by grouping and even our bridge trinomial skills. So those are going to come back to play a little bit, especially when we deal with polynomial equations. But the basic rules for polynomial equations are the same. We're going to look to factor the expression that we are given. If it's 4 terms, we'll work grouping. If it's 3 terms, we might have to use bridge trinomial. It all depends on the actual setup that we see. But once we factor completely, and we're left with those basic factors set equal to 0, we're going to solve each root individually. We'll create our t-chart and solve appropriately. Now, in some instances, very rare, but it may happen, one of the 2 factors, or one of the 3 factors, or however many there are, may not be able to be factored further. And thus, we may have to bring into play the quadratic formula. But we'll take a look at that towards the end. You guys will get the idea. It's very easy. And again, it's just taking care of maybe one piece that may not work. So to show you how this is all set up, let's take a look at our examples here. And we'll start with number 2. So hopefully you realize that we are set in standard form, which is exactly what we're looking to do with quadratics, and it's exactly what we're looking to do with polynomial equations. If you're not in standard form, do the things you need to do to get it set up. With that, we now see that we have that four-nomial expression, or that polynomial with 4 different terms on the left side. Well, as we know from our factoring, we're going to look to factor this guy by grouping. So we're going to split it down the middle and do our basic factor by grouping skills. On the left side, we have a GCF of x squared, leaving us with 2x minus 3. On the right side, we need to take out a negative 4, so we get that corresponding 2x minus 3 in return. Well, hopefully you remember that after we factor by grouping, we're going to group those GCFs together and create our binomial factors. Notice they are set equal to 0. But as always, if we can factor further, we will. And we notice that we have the difference of 2 squares on the left. And after we factor completely, this is the setup we are left with. We have 3 factors that are now set equal to 0. All that remains is to solve each individual factor for x. So we get one root value of negative 2. We get another root value of positive 2. And we get a third root value of 3/2 or 1.5. Either way you want to look at it. And that would be your factoring by grouping in order to solve your polynomial equation. As long as you know your factor by grouping skill, it's a pretty straightforward concept. There's nothing too difficult here that you guys have not handled before. And like I said, just make sure all those key things for quadratics come back into play. Setting ourselves up in standard form, factoring completely, and then solving accordingly. Now, in some instances, like in example 6 here, we may not have 4 terms. So if we set this guy into standard form, we will notice that we're actually left with what looks like a trinomial. But it is not a quadratic trinomial. So we need to factor this guy in whatever possible method we can. And if we do so correctly, hopefully you guys notice that this entire trinomial has a GCF of 2x squared. From there, we're left with x squared minus 5x plus 9 equals 0. Now, unfortunately, that x squared minus 5x plus 9 is not factorable any further. So we're left with as far as we can go in terms of our factors. So to finish this, well, the left side's pretty easy. We're going to set that guy equal to 0 and solve for x. In this case, we get a value of x equals 0. But on the right side, since this is not factorable, we actually have to solve it in one of our alternate methods, either completing the square or our quadratic formula. And in this case, the quadratic formula is what works best. Now, it's very rare that this does happen, but on the occasion that it does, you guys just need to use the skills that you know in order to solve it properly. And if you finished all this out, if you decide to try this on your own, you would get a final value or a final set of roots that is imaginary. And again, this solution comes from actually doing the quadratic formula work, which you guys know how to do. But like I said, it's rare that that occurs. Mostly you will see what we saw earlier with your polynomial function having 4 terms, which is completely factorable, setting everything equal to 0 and solving accordingly. However, if you do meet that rare occasion that you cannot factor, you will use your either completing the square or quadratic formula method that's necessary. And there's your entire concept of polynomial equations. Now, one last thing we want to share with you guys is how to deal with graphing or graph-based questions of polynomial functions. So what you'll notice in this example here is you have a graph of a polynomial function. We don't have its equation. We don't have any information about it other than what it looks like. But the question is asking us to find the roots of this polynomial. Well, as we know, just like in a parabola, we are looking for what are known as the x-intercepts. In other words, we're looking for where this thing is hitting the x-axis. Well, just like a parabola does, a polynomial equation can do the same thing. And if you take a look, this function is hitting the x-axis in 4 different locations. It has root values of -3, of 0, of 1, and of 2. And again, all of these are x equals values. Right? So really nothing to trick you there, just understanding that roots of polynomial equations follow the same concept of roots of quadratics. They are the x-intercepts. They are the locations where the graph hits the x-axis. So with that, guys, there is your entire concept of polynomial equations. Solving is really just repeating the skill of factoring by grouping, especially when we have the four-nomial or the 4-termed polynomial. And in some instances, you may have to use a skill other than factoring to get your final answer. While that is rare, it is a possibility, and we'll look at more examples like that together. Hope you guys enjoy the rest of your weekend, and I'll see you on Monday to continue up and follow up with our work with polynomial equations. Have a good one.